I'm building a Helix on Ron's Trains and Things right now. Hi, I'm Ron of Ron's Trains and Things, and if you'd like to see more model railroad tips, tools, and techniques, then be sure to subscribe down below and click that little bell icon so you can catch future videos. Well, those of you who follow this channel know that over the course of the past several months, I have been working on an expansion to my layout. And the one thing I've been working on most recently, and that has kind of been the holdup on that expansion, has been the Helix that's going to connect the two decks together. Now, this Helix has taken me a lot longer to build than I expected, and I've had a number of obstacles that have gotten in the way. It's taken me about 2.5 months, but I have finally completed the Helix. So let me show you exactly how I built this Helix from start to finish, and we're going to do it right now. Visit our sponsor, Midwest Model Railroad. Their new location with 5,500 square feet of inventory and next day shipping make them your premier model railroad destination. MidwestModelRR.com. Link in the description. Well, to start off this project, I am sitting literally right where the Helix is going to be built and where it's going to be sitting very, very soon. Just to show you the first step that I've already taken in this project to kind of get it started, and that is right here. This area right here is where the track is going to come from the lower deck through the wall onto the Helix. And I went ahead and took the step of putting in this board right here in between these two studs. This is just a piece of a nice straight 1x4 that I went ahead and cut to fit snugly in between these two studs. Used a level to make sure that it was nice and flush with the sub road bed on the lower deck, and make sure that it was nice and level, and got that screwed into place. I also went ahead and marked the track center on this board as well, where it's going to come through the wall. I did that using this handy dandy little tool right here. This is called a track setter from Melcam Models, and it is a curved track gauge, and this particular one is for 18-inch curves, which is kind of the standard for my layout generally speaking. And it's helpful not only for keeping the track in gauge as you go around curves, but it's also handy for being able to mark out these curves as well in places where you can't get a compass in, such as where it comes through this wall. So I've got that much done. The one other thing I need to do before I really start building the Helix is you'll notice that this wall behind me, I've hung drywall on it up to this point right behind me. I'm going to go cut this sheet of drywall, get it screwed in, and probably actually need to go ahead and tape and bed this before I actually start building the Helix. So we're going to get that done, and then we're going to get started actually building a Helix. Well, you caught me sitting down again, but I'm waiting for that first coat of drywall mud to dry on the other side of the wall. So we're going to be another day before we can do any more work over there. But I'm going to begin assembling the parts of the base to my Helix. And the first thing that I'm going to be doing is assembling the legs. Now I'm going to make L-shaped legs out of 1x4s. I've cut these to 35 inches. That'll give me enough room on top of the base to have some play and some room for some of the hardware that I'll need. You'll see that a little bit later. But I'm going to be taking pairs of these 35-inch 1x4s and screwing them together in an L shape like this to give me a good strong leg for each corner of the base. And as I do this, I'll show you a little mock-up that I drew of how the base is going to work. Sometimes whenever I'm doing some work like this, I can do a lot of kind of figuring and adjusting and planning in my head, but sometimes you just need to put pencil to paper. And in this case, I did just that. It's a lot easier for me to do this on paper with some simple geometry and math than it is for me to do in a CAD program, just because I don't have as much experience in that. So here's a drawing that I drew of how the base is going to be supported. And we'll talk a little bit about how this is going to work as we go. But for right now, I've got 4 of these pairs of 1x4s have to be screwed together to make the corner legs. So we're going to work on that and get that done right now. This is where the helix is going to sit. You can see I've already cut a couple of openings in the wall. This one where the trains will come off of the lower deck into the helix, and one on the other side that will be where trains go into a small staging yard that'll be down here on this side of the wall. But that's a project for another day. Now it's time to get the framework and the base for this helix built so we can start putting the helix together. I built the frame for the base support structure of my helix using 2x4s. I used framing lumber, so it was a little rough, but it'll make a sturdy base for this project. I sanded the 2x4s a bit to knock some of the rough areas down and to remove splinters. I started with the two longest sills of the frame and marked the placement of the cross pieces. My helix will be a total of 48 inches in diameter. To allow room for the thickness of the frame and for the threaded rods to mount into the top of the base, I built the frame base 53 inches square. I screwed the frame together with 3-inch drywall screws. When I had the box frame assembled, I checked it for squareness by measuring corner to corner in both directions. I strung 2 joists across the support, then framed the center hole. When the frame was assembled, I attached it to the legs with clamps with a little help from my son. I then set the height and leveled the top in every direction before screwing the legs into place. I cut the 3/4 inch plywood for the top and checked its fit. Since the base is more than 4 feet wide, I had to cut the top in 2 pieces. I test fit the top and marked the center hole for cutting. When I was satisfied with the fit, I screwed the top to the frame. I added a couple of cross members at the seam of the plywood pieces to ensure they wouldn't sag under the weight of the helix. I tested my ability to get inside the helix and found it much easier to get inside than my old one. As you can see, the base structure is quite strong. I'm ready finally to start laying out and cutting the turns for this helix. Now I'm going to tell you right off the bat here, the method that I'm using generally is a tried and true method. A lot of people have used this same method with great success. It is not the only method for building a helix by any means. In fact, it's not the same method that I used on my previous helix. But I think it's going to work really well for me today. Now there are some specifics to what I'm doing that are kind of my preference. It's how I'm choosing to do it, and there's some different ways of doing that, especially with regard to how I'm cutting this out. My previous layout, I used the block method, where you use blocks of the right size, the right distance in between the various levels. And for doing that, I cut quarter turns for making the turns on my helix, so that there were 4 of these for each full turn on the helix. This saved a lot of plywood. However, with the method that I'm using today, I'm going to be using the threaded rod method, and I just think I'm going to get a lot more consistent grade up each turn if I have a solid piece of plywood for each turn. So I'm literally going to be cutting out full circles. Now I know that means I'm going to have some waste to my plywood, but having done this method, I realize I'm not going to waste as much as I think. There have been Some other methods that people have used doing a hexagonal type of construction for a helix that probably wastes much less plywood and comes out looking really, really good. But there's a lot of math involved, and I've just decided that cutting these full turns is going to work the best for me. I have started the process of laying out the first turn, and assuming that that all goes well, that'll become the template for all of the turns on the layout. I made myself a compass, just a homemade compass. I used just a scrap. You can use a scrap of anything that's thin. In this case, this is just a scrap of 1/8" masonite. And I set out on it the different diameters that I need to mark. I've got a hole on one end, which is my center or pivot spot, and then I measured exactly from there to the very outside of the plywood, which is 24 inches, to the far inside of the sub road bed, which is 19.5 inches, and then I have holes for the two radii for my track, for my center lines. So I'll go ahead and be marking those center lines as I go, and that way whenever I get down to assembling this thing, putting track on it, that'll already be done. I don't have to worry about doing that again later. Once I get that all laid out, I'm going to mark those ears that I was talking about, and this will make more sense as you see it, but I've got a little lid here that is exactly 2 inches in diameter, which means that half of this lid would give me a 1-inch protrusion, a little curved ear, which is what I'm going to bolt my turns through onto the threaded rod. So I'll be using these to mark that out. With my turns laid out on the plywood, I used a 1/2-inch drill bit and drilled holes at every inside corner where my mounting ears met the turn. This allows the jigsaw blade to make the sharp, almost 90-degree turn without binding. I sanded these holes a bit to remove larger burrs of wood that would interfere with the base plate of the jigsaw. Then it was time to start cutting. I cut around the outside perimeter of the turn first. I tried to work slowly around the mounting ears, as these sharp curves are the most challenging part of cutting the turns. When the outside excess was removed, it was time to cut the inside circle. I sanded all of the edges, top and bottom, to remove burrs and splinters. I got my first turn completely cut out. Carried it down and just laid it on the base just to see that everything is going to line up and work. I think it's going to be fantastic. You'll see that in just a few moments. With that, it was just a matter of wash, rinse, and repeat. Only 7.5 turns to go. By the time I cut all of these out, it took me something over 6 hours altogether over the course of a couple of days to cut all of these out. Now I'm mounting this Helix. I'm building it out of 1/4 threaded rod. Those of you who don't know, that means this is a quarter inch in diameter and 20 threads per inch, which matches like what is used for typical camera gear and other electronics. So I'm going to be using 1/4, and I've got these are actually 36 inches long, so they're longer than I need. I'll ultimately be cutting some length off of the top. I want to make sure that whenever I thread them through the various levels of the Helix and down into my base, that they go straight down through. I've seen several people, and I'm not trying to be critical, but I've seen several who have made helices like this, and they didn't get their mounting holes lined up, and so their threaded rod bends and twists going from one level to the next. I don't want to have to mess with that. So I've stacked all of my turns up here and I've got them all lined up with one another, and they're set exactly where they will mount onto the base. And I'm going to drill straight down through all of those mounting ears so that all the holes line up. To do that, I'm using a 5/16 inch paddle bit, and this is long enough it's going to allow me to drill all the way through all the ears and at least start or mark the hole into the 3/4 inch plywood on the base, so I make sure that I get my holes lined up on the base as well. I drilled through my turns and the base, then put one of the threaded rods into the holes. Once I had 2 of these rods in place, I knew the pieces couldn't move and would remain lined up in place. I continued the process until all of the holes were drilled. This first level is going to be maybe in some ways the trickiest, because I've got to get the first level of the helix on and also get the threaded rods mounted at the same time, get them mounted to the base. So I'm going to try to do that from the top. All of the other levels to the helix will have to go onto the threaded rods from the top down. For these, I'm going to try to put the threaded rods down through this level. I'll have to thread them through some nuts in between the first turn and the base, and then of course put some washers and nuts on the bottom to mount the threaded rods and get them in good and solid. Getting the first level in place really is the most challenging. I had to juggle getting the rods mounted to the base with a nut and washer below and above the base, and getting the grade where I needed it to be and stabilized. It's important to take your time here, because if you get the first turn wrong, the whole helix will be wrong. When I had all of the threaded rods mounted in the base and the first turn, it was time to set the grade. For this, I used my digital level. This tool is absolutely indispensable for building grades, and I can't imagine building a helix without one. When setting grades, a lot of checking and adjusting and rechecking is required. Each time I adjusted one section, it would change the tension and thus the grade on the adjacent sections. So I would grade one section, then the next, then go back to the previous section, readjust, and so on. It took several go-arounds on each turn to get the grade as consistent as I wanted it. Now it's time to lay track on this first turn and to install the feeder wires so I can then go on and install the subsequent turns. We're going to work on that in just a moment. I did this morning go ahead and cut a bridge piece, which you see over here, which connects the bottom of the helix to the lower deck of the layout where it goes through the wall over there. There's a turnout there because this is a double track helix, but it's only a single track where it goes through the wall and on to the main part of the layout. So I've got a turnout there to connect the single track into both tracks of the helix. Laying track on a helix is its own unique challenge, as the entire helix is one big curve. I soldered every rail joint in the helix. I used slightly thicker than usual application of latex caulk to glue it down. Use a pair of track nails at every joint to avoid kinks where they might be most likely to occur, and install a set of feeder wires on every turn. I used push pins to hold the track in place while I was working on it. I made a separate video all about how I lay curved track in a helix, and I'll include a link to it in the end screen at the end of this video. Now it's time to start the wiring process. It's going to be a lot easier if I wire this thing as I go. Just as I covered laying track in the helix in a separate video, I realized post-production that the wiring segment was going to make this video entirely too long, so I'm covering the wiring in a separate video as well. Watch for that video next week, or if it's already been produced, you'll find it in a link in the iCard in the upper right-hand corner of your screen right now. You can never test track too much, so after laying and wiring each turn, I ran a test train up and down several times at various speeds on each of the two tracks, watching for any bumps or imperfections that affected the train in any way. More than anywhere else on the layout, track in the helix has to be perfect. there's little chance of fixing it once the Helix is built, so now is the time to catch and fix any bugs. The trick in building the Helix is in the first 2 turns. The first turn, of course, as you've seen, getting the grade exactly right, getting everything started off right. The second turn, getting the spaces just right between the 2 and getting the process of the stacking part of the Helix done. Now, the most tedious part of this entire process is threading the nuts on these threaded rods. On the first turn, I put all the nuts on from the bottom, so I only had to go a few inches. But from there on out, they all have to go on at the top, and in my case, on the lower turns, they have to thread down about 2.5 feet. Now, I found out that this was going to be a long, tedious process very quickly. Fortunately, my good friend Eric Hall reminded me of a process that I had seen in the past but had completely forgotten about. It's a tool that I made for myself by literally taking a scrap of foam, in my case, a scrap of 1.5-inch foam that I had lying around. I cut it into the best circle that I could with a knife. Then I went out to my garage, in that bucket that we all have filled with nuts and bolts and other small hardware from various projects over the years, and I found a nice long bolt that was small enough to chuck into my drill. And I also found 2 washers and a nut that would fit that bolt. I then punched a hole through the circle of foam as near the center as I could, put a washer on the bolt, put the foam on the bolt on top of that washer, put the other washer on, tightened the nut down until the washer started to pull into the foam, so I knew it was good and tight. I then chucked the bolt into my cordless drill, used a piece of coarse 60 grit sandpaper to sand the edges while turning it into my drill to make it nice and round and fairly smooth. And this made a great tool for running these bolts, or running these nuts down these threaded rods. Now, these rods, as they came from the store, had some stickers on them with the UPC symbols, and when it would get to the sticker, I would have to hand turn it for about 1 inch to get past where the sticker was, as the sticky part was still on the threads. Once I got past that, I literally saved myself 80% of the time it was going to take me. It took me 3 minutes to thread a nut all the way down one of these threaded rods all the way to the bottom. With this drill and this homemade tool, I could do it in 30 seconds. So that's something you may want to try if this is a process that you're doing in building a Helix for yourself. Now I've got all of those nuts and the washers on that will go underneath the second turn of the Helix. I also made myself some spacer blocks just to help me basically measure out the distance in between the turns of the Helix. In this case, the space in between the top of one turn and the bottom of the next turn is 2 5/16 inches. So I use them to basically set where these nuts and washers are, and then we'll adjust with the level once we get the turn in place. On each turn, I connected the top of the turn to the bottom of the next turn with these straight steel straps and wood screws. At this point, it was again just wash, rinse, and repeat. Installing washers, nuts, adjusting the grade, laying track, wiring on every level of the Helix. Once the Helix was completed, I had about 10 to 11 inches of threaded rod still above the track on every rod. I cut these off with a metal cutting blade and my oscillating tool and threaded a cap nut on top of each one to protect against injury and to give a nice finished look. Cutting the rod leaves behind lots of tiny metal burrs. These will be picked up by the magnets in the motors of locomotives, so I used a magnet from an old car speaker to collect them. One tip here: place your magnet inside a plastic sandwich bag when doing this. Then hold the bag over a trash can and remove the magnet from it, and shake it out, and all of the shards will fall away into the trash can. Otherwise, they are nearly impossible to get off of the magnet completely. And with that, my Helix is complete and ready to transport trains between the decks of my newly expanded layout. I am so glad to have this Helix finally completed, partly because it means I can move on to some much more exciting and satisfying modeling projects, like beginning to lay track, beginning to be able to operate trains from end to end on my layout again, and also very excited about some scenery projects that are coming up on this new part of the layout, and I'll be showing you all of that as we do it. I am very happy with the way the Helix turned out. Again, the testing and testing and testing as I went means that it absolutely runs like a dream. I've had no hitches, no bumps, no derailments on the many times that I've run both loops, and that makes me very, very happy. And it means that we should have satisfying operations as we go from deck to deck on the layout once we get this expansion completed. Now, I talked in the video about my digital level, and I gotta tell you, it is one of the most exciting new tools that I have bought in the last year. I mentioned it a few videos back as I was working on fixing some grades on the expansion part of the layout where it connects to the existing layout, and many of you were excited about it, and many of you purchased it, but I'm gonna tell you, if you are working on grades or if you're building a Helix, it is an absolute must-have tool. And if you haven't picked one up, I'm going to encourage you to do so. I'm going to include a link to one in my Amazon pick of the week in the description down below, as well as a couple other tools that I think you'll find interesting. Be sure and check those out. Well, hey, you can see all of the work that I'm doing on this expansion to my layout in a playlist that is linked in the corner of your screen right now. You'll want to check that out. Also, be sure and check the description for that Amazon pick of the week, a link to my Amazon page, and my MicroMark promo code that'll save you a few dollars at micromark.com. Well, if you'd like some more Model Railroad content right now, check out the links on your screen. And be sure and join me each Tuesday as I bring you even more great Model Railroad videos, and I look forward to seeing you then. 10, Lizzie?